Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video, we will be discussing question number 41, NEET Physics paper 2015. Students, the question is, the fundamental frequency of a closed organ pipe of length 20 centimeter. This is a closed organ pipe and the length of this closed organ pipe is 20 centimeter, and the fundamental frequency, its fundamental frequency will be, the vibration will be in this mode. This is anti-node and this is node. This is the distance is lambda by 4 is equal to, the fundamental frequency is equal to, suppose the fundamental frequency is NC for frequency in closed organ pipe, that is equal to, so it's given that it is equal to second overturn of an organ pipe open at both ends. So if I have a pipe which is open at both ends, let the length of this pipe is LO, O stands for open, C stands for closed. The second overturn of this, the second overturn open pipe, the length of the organ pipe open at both ends. So you have to find actually LO when the frequency, fundamental frequency of this mode is equal to second overturn of open tube. Second overturn of open tube. What is second overturn in open tube? Suppose that the fundamental frequency in open tube is NO, and we know that the all possible harmonics or vibrations in case of open tube is, here the fundamental frequency is like this. This is the fundamental frequency. This is always anti-node because it's open, and this is the node here. This is the fundamental mode of vibration, and this is the fundamental mode of vibration in closed tube. So I have just given the comparison. This is for closed one and this is for open tube. So it is given that this is equal to second overturn. What is the overturn here in open tube? The vibrations are NO, 2NO, 3NO and 4NO and so on, all integer multiple of NO. This is the fundamental frequency or first harmonic, this is second harmonic, this is third harmonic, but we are interested in overturn. After fundamental, whatever is left, this is the first overturn, this is the second overturn, second overturn. This second overturn in open tube is matching the this, so this is 3N naught. This is given in the question. So you have to use the formula to solve this. Now what is given? This is given that NC is 3N naught. What is the formula for NC? This is V upon 4L. Okay, and NO is V upon 2L. This is known to us. Okay, how this is done? Because you can see that velocity is frequency to wavelength. Velocity is frequency into wavelength, and the frequency is velocity upon wavelength. And what is this wavelength? Now you can see that this length accommodates lambda by 4 wavelength. LC equals to lambda by 4, so lambda is equal to 4 LC. So lambda is 4 LC. If I put here, then it's 4L. L means it's actually L for the closed tube. Similarly for open tube, it will be 2 because this length is lambda by 2. So therefore it is 2 here and 4 there. Now if I substitute the value V over 4LC, length in closed tube, equals to 3 times V over 2LO. Okay, the speed will remain the same. If we change the tube, the speed of sound will not change. So from here I can write that V will cancel out, this 2 and this 4 is giving you 2. If I cross multiply, then this is 3LC multiplied 3, that is 6LC, and that becomes L naught. we're interested in the length of the open tube, the length of open organ pipe. That means we're interested in LO. So this LO equals to 6 times LC. What is LC given here? Is 20. Okay, LC is given 20. So then I'll put here 6 into 20. So this becomes 120 centimeter. So length of the open tube is 1 centimeter. Okay. So if I see the answers, then option number 1 again is correct answer to this question. Okay, thank you.